Hi everyone. In the initial video in this section, we talked about comparisons of two groups and comparisons of population means in general. And then we talked about the fact that there's two types of samples. Essentially, there's two methods to compare two groups, one for independent samples and one for dependent samples. We're going to begin our unit on two sample comparisons. We'll look at dependent samples confidence intervals. Here's the problem. A psychologist believes that a program of mental exercise, puzzles or something like that, will improve short-term memory. A random sample of 50 adults are given 30 minutes to memorize a list of words. At the end of the 30 minutes, these subjects complete a recall pretest. So how many words can you remember from this list? The subjects then complete 4 weeks of regular mental exercise. So they might be doing Sudokus or crossword puzzles or word searches, things like that. At the end of the 4 weeks, the students are given a second list of 50 words. They're told to study those words, and after 30 minutes, they're asked, how many words can you recall? For each subject, the post-test and pre-test scores are compared. And note that what I talked about here is a difference. I'm comparing through a difference, D we'll call it, of post-test and pre-test. Post-test score minus pre-test score. The first question you need to ask yourself is, what type of samples are these? We've got a set of post-test scores, a set of pre-test scores, 15 of each. Okay, what are these samples? These are dependent samples. And why are they dependent? A sec, let me get my pen going. Why are they dependent? It's given to you in the very last sentence rather. It says for each subject, the post-test score is compared to the pre-test score. So if you think samples are dependent, tell me what's being compared. These are dependent samples because for each subject, the score on the post-test is compared to the score on the pre-test. Here's a quick look at the data, and I'll bring it up in StatCrunch in a bit. You've got the subject, so subject numbers 1 through 15. I don't have all of them on here. Their pre-test score, their post-test score, and then the difference. So now notice what I've done here. I've just subtracted post-test 26 minus pre-test. That equals 2. Post-test as 24 minus pretest, which is 17, equals 7, and so forth. So that's what I mean by comparison. You're actually finding these differences. All right, so the first thing we want to do is estimate. We were wondering, what do we know about the differences of post-test and pre-test scores? You've already seen in the initial overview video that what we do is we forget about the fact that we have a pre-test and post-test, and we just focus on the column of differences. What do I know about this column of differences in the post-test and pre-test? So I want to estimate, say with 95% confidence, the mean of the difference in recall scores, D, for the post-test minus the pre-test among all adults completing memory exercises. The first approach I'm going to use is just by hand. Okay, here is the confidence interval for dependent samples, and it is, let me get my pen going, x bar of D plus a critical value, T of C, that's related to the confidence and the degrees of freedom, times S of D over the square root of N of D. That's the formula for the dependent samples confidence interval. Notice we need some things from the data. We need x bar of D and S of D and N of D. To get that, and this is why I say this is by hand mostly, we need to go to StatCrunch. So you have the column of differences here. If you want to get x bar of D, the sample mean, and the S of D, the sample standard deviation, you need to go to Stat and Summary Statistics. And on a column, there you go. And on the column of differences, compute that. And notice what it does is it gives us a value, it gives us the differences. Okay, what I've done is I've created that on this page. Okay, so here it is. Here's the column of differences. This is copied from StatCrunch. The N, the sample size, is 15. We've got 15 individuals. X bar of D is the sample mean in that table. S of D is the sample standard deviation. So with this, we can just plug the information in. We've got X bar of D, which is 2.467, round to 3 decimal places, plus or minus some critical value. Now, where do we get that critical value? That critical value for 99% confidence, we've got 15 differences. Number of differences is how you find your sample size, -1. So go to the T confidence table, 14 degrees of freedom, 15 minus 1, 99% confidence, 2.977 is the value. So we've got the critical value, 2.977, times the standard deviation, which is 2.356, over the square root of the sample size, and that is 15, the sample size. So we'd do that calculation, plus or minus, you'd get a top end, an upper limit, and a lower limit. One thing to notice, it may make your job a little easier. This portion right here of the formula, what's in the parentheses, is called the standard error. And notice that when you compute the summary statistics, the standard error is given to you right here. So I could actually make my life a little bit easier. On the next page, I've actually given you the formula. Again, plugging in, instead of having to do the square root and a little more complicated computations, I have the sample mean minus, for the bottom end, the T critical value, times, and right here is your standard error. Again, this whole portion right there is called the standard error. When I do these computations for the lower end and upper end, I get a lower end of 0.6558, an upper end of 4.278. So with a confidence interval, give me your formula that you're using, which is up here. Show me the calculations if you're doing it by hand, and then the interpretation. We're 99% confident that the mean of the differences, because we're estimating mean of the differences, mu of the differences in recall scores among all adults, is between 0.66 and 4.28. Now, it's good. I like to interpret that a little bit farther. Our differences are post-test minus pre-test. These differences are between positive 0.66 and positive 4.28. What does that include or imply? On average, the only way you get positive values is if the post-test is greater than the pre-test. So on average, we can conclude that the post-test scores are between 0.66 and 4.28 points higher than the pre-test scores. That's doing this problem by hand. I will ask you to do some by hand, but with technology, we can actually shorten this process. So we're going to actually pose the same question, and I'll show you how to generate the confidence interval with StatCrunch. As with all problems that you do a confidence interval, the first thing you want to start with is give me the formula. You're doing a confidence interval for the mean of dependent samples. If I go to StatCrunch, and for the confidence interval, I need to go to Stat and T-Stats, and dependent samples are paired samples, so click paired. The test, you have to select the first group. Remember, the differences are post-test minus pre-test. On StatCrunch, it's always sample 1 minus sample 2. For sample 1, therefore, I'm going to choose post-test scores. Minus sample 2, I'm going to choose pre-test scores. I need to tell, so scroll down, I need to tell StatCrunch that I want to do a confidence interval, and this is for 99%, and I compute. And notice what you have, lower limit and upper limit, lower limit in that line right there. So back to my PowerPoint slide. I've copied the StatCrunch file. After computing this confidence interval with StatCrunch, I have the lower limit, I have the upper limit of the mean of the set of differences. So I'd like to then just give my interpretation. We are 99% confident that the mean of the differences in recall scores among all adults is between 0.66 and 4.28. In other words, it's going to reach the same conclusion. It's just how you get there, doing the calculations by hand versus doing them with StatCrunch. One last question, which is true about all procedures that we do in statistics. Is the process valid? We already know that from the problem that the sample of paired differences in test scores was randomly selected. The standard deviation of the differences in test scores for all individuals is known. There's a bit of a red flag, though. The sample size is less than 30. If that's the case, remember we have another out for t distributions. And I'm going to go to the StatCrunch again. Let's examine the histogram of the sample differences. So go to graph, and histogram, of sample differences, compute, and there it is. I've posted this copied it onto my PowerPoint file. So the sample size is less than 15. That's a red flag. But if I examine this sample of differences, which look relatively symmetric, these sample of differences suggest that the difference in test scores for all individuals is normal. So we have a random sample of difference in test scores. The standard deviation of the test scores for all students is unknown. And the sample, or the population, it is suggested is normal. So the process is valid.